Lesson on Straight Line Graphs Part 2. In this lesson, we will look at the general equation for straight lines. We will find out what is the gradient and the y-intercept. We will find gradients from two given points and how to determine an equation from a graph and how to sketch a line from a given equation. The general equation of a straight line. We have seen from the previous lesson that the equations below gives us straight lines. In fact, all equations which can be written as y equals a number times x plus another number are straight lines. We call this the general equation of a straight line, which we write as y equals mx plus c, where m and c are numbers. Whenever we want to describe a straight line, we need to describe the slope, which is also called the gradient, and where it cuts on the y-axis, which is called the y-intercept. By writing the equation as y equals to mx plus c, we can get the gradient or the slope and c, the y-intercept. Hence, the equation y equals to 2x plus 5 has a gradient of 2 and cuts the y-axis at 5. The equation 2x plus 3y equals to 6 can be written as y equals to negative 2/3 x plus 3. In this way, we can get the gradient, which is negative 2/3, and the y-intercept, which is 3. The gradient m describes the steepness of the slope, and the steepness is measured by the ratio height over base of a right-angled triangle. An example, this line has gradient 2/6. And this line has gradient 3/5, the height of a right-angled triangle over the base. The gradient is negative when the line slopes down to the right. This line has gradient negative 2/5. And this line has gradient negative 3/5. The y-intercept is the value of y where the line cuts the y-axis. Currently, the y-intercept is at -1. Now the y-intercept is at -3. The y-intercept is now at 5. Knowing the gradient and the y-intercept, we are able to find the equation of the line. The gradient here is 3 and the y-intercept is -1. Therefore, our equation is y equals 3x plus -1. Changing the gradient, we get a new line. Similarly, if we change the y-intercept, the new line equation is y equals gradient 5x plus c, the y-intercept 2. It is possible to find the gradient from two given points if we know the coordinates of the points. As in this case, point A 5, 7, point B 2, 3. The difference in the y-ordinates gives us the height of the triangle, and the difference in the x-ordinate gives us the base of the right-angled triangle. Thus, the gradient is 7 minus 3 over 5 minus 2, which gives us a gradient of 4 over 3. And this line has gradient difference in y 5 minus 3 over 5 minus 2, which gives us a gradient of 2/3. If the line points in the other direction, then the gradient is negative. As we can see, the difference in the y-ordinates 7 minus 3 over -1 minus 2, which gives us a gradient of -4 over 3. Thus, using this method, the sign in the gradient is taken care of. We'll now take a look at how we obtain the equation of a line from a diagram. We must identify what is the gradient and y-intercept for each case. The y-intercept in the first example is at 4. And the gradient, which is formed by the right-angled triangle, is 4 over 2, which is 2. Hence, our straight line equation is y equals to gradient times x plus y-intercept 4. In the second example, the y-intercept is at -3. But the line slopes down to the right, therefore it is a negative gradient. The height here is 3 and the base is 4. Thus, the equation of the line is y equals to gradient, which is -3/4 x plus -3. In this example, the line cuts through the origin, which is at 0, and the gradient is obtained from a given point. The height of this triangle is the y-ordinate, and the base is the x-ordinate. The gradient is 4 over 3. And the equation is y equals to 4 over 3x plus 0, which we do not show. In the last example, we can identify the y-intercept easily, but for the gradient, we will have to find the difference in the height, which is 3 minus 2 is 1, and the base is 5. Since the line slopes down to the right, the gradient is -1/5. Therefore, the equation is -1/5 x plus 3. We will now see how to obtain the equation of a line given 2 points. We must first find the gradient, which is obtained by the difference in y over difference in x, which is 3 over 2. Knowing the gradient gives us the partial equation, which is y equals gradient times x plus the y-intercept. Our next task is to find the y-intercept. To do so, we substitute one of the points. In this case, we choose 1, 2. We substitute it into the equation. Y is 2 and x is 1, giving us c is half. Therefore, the equation of the line is y equals gradient times x plus the y-intercept c. We now look at the equation of horizontal lines. Horizontal lines have the equation y equals to the y-intercept. The y-intercept is now at -5, so this line has equation y equals -5. The line now passes through the y-intercept 1, so the equation of the line is y equals to 1. Now the line passes through y equals to 5. So the equation is y equals to 5. Similarly, for the equation of vertical lines, the equation is x equals to the x-intercept. X-intercept is now at 1.5. The equation of this line is x equals 1.5. The x-intercept is now at 3. The equation of this line is x equals to 3. Parallel lines have the same gradient. As in this case, these two lines are parallel because they have the same gradient too. They have different y-intercepts but the same gradient. You can see that the y-intercept changes but the lines remain parallel because of the gradient. Let us now see how we can sketch a straight line from an equation. There are two methods shown here. In the first method, we want to find the x and y intercepts. By putting x as 0, we can obtain the y-intercept. Thus, the y-intercept is 5/3. Putting y as 0, we can get the x-intercept. Drawing the line through the x and y intercept gives us our required line, which is 2x plus 3y equals to 5. In the second example, we make use of the gradient and the y-intercept to draw the line. We first identify the y-intercept, which is 1. From the y-intercept, we draw a triangle which represents the gradient, height 2 and base 3 from the y-intercept. Thus, from the y-intercept, we draw a base of 3 and a height of 2. From 1 to 3 is 2. Thus, we have the point 3, 3. Now we have 2 points. Joining the points will give us the straight line. So in method 2, we need to first identify the y-intercept, and from the y-intercept we draw our triangle of base 3 and height 2 to get a new point. Joining the 2 points will give us the straight lines. When we want to sketch a straight line, we need to show the x and y intercept. Thus, in this example, we still need to find out what is the x-intercept. Let us now take a look at more examples. In this example, when x is 0, y is 3. And when y is 0, x is 3/2. Therefore, the x and y intercept, y is 3 and x is 3/2. And joining the 2 intercepts gives us the line. In this case, we need to use the second method, as the first method will not work, since when x is 0, y is 0. When y is 0, x is also 0, because it passes through 0. Now we need to draw a triangle of height 3 and base 2. Okay, base 2 and height 3. And this gives us the required line. We need to put down the coordinates of the point. Next example. Again, when x is 0, y is 1. When y is 0, x is 2. Thus, we have our x and y intercept. X is 2, y is 1. And joining the 2 intercepts gives us our straight line. Notice that the line has a negative gradient. Again, we have a negative gradient, but when we identify the x and y intercept, the slopes take care of itself. When x is 0, y is 3, or this can be readily seen from here, minus 3. And when y is 0, x is negative 3/2. Okay, so x is negative 3/2 and y is negative 3. And this is our required line. This completes the second part of straight line graphs. Thank you.